library has gone through a couple of iterations now. And is it still possible to just say that I want the way that I know my chip is going to interpret this anyway, and let the devil take the details, and just take the absolute bare minimum and get that out of your library, because I mean otherwise people are going to continue building their own fixed point libraries.
Right.
Idea.
Right, so the approach I'm taking, you by default you specialize these types, they're numeric components, you specialize them, well, instantiate on int, and the default is typically int, and int is usually for most people and most domains it's the most efficient numeric type you will have on your system. However, if you come up with your own type which exploits exotic hardware and behaves reasonably closely like an int, you can use that. So to begin with, you can use any of the char, short, long, or anything else. So if you can come up with a custom type that is 17 bits in width, but it still does addition and multiplication and can be converted to floats, then you can do all of those things, but then also use it as a fixed point type or catch overflow with it by combining both. I'm not sure if any of you would consider any of the devices that use ES to actually be embedded, but that's what the E stands for, and it would at least have familiarity with a lot of people who would be interested in using it, because I'd like to see a library that works for embedded, probably would be viable for game development too.
Yeah. Well, embedded or not embedded is not the point.
Not really, no.
It's more efficient on running on intervals.
Right.
So I think an embedded namespace or something would be beside the point. It's the separate features, like running on integers or on-stack containers or something like that.
Yeah, I agree that we should be cautious about naming something in the standard after a domain.
Yeah.
Especially a domain that is as diverse as embedded.
Yeah.
Like few domains
We don't even know what embedded is.
at the same time.
Into namespaces.
If you called it embedded, game developers would just go, oh, like GLEX, and then just start using it. They would have no problem using it, because they would know that it's the kind of philosophy behind it.
But then you'd have the problem that the stuff that does have a GLES is regarded embedded, and the UER is considered embedded, and it's not really this.
And supercomputers are considered embedded as well. Like, CERN is an embedded device. So
I really do see that. I really see that the two ends are now circling and joining with each other. I mean, they used to be what's pulling apart, but nowadays you've got automobiles that are essentially supercomputers on wheels, right? And supercomputers are trying to use commodity devices, because they no longer believe that they should build these one-off blue whales, which is what they used to call these IBM machines, that you only build one off. and you never build another one again.
It's actually amazing, because the robotics problem and the self-driving car problem is essentially people trying to run supercomputers in hard real time.
Yeah.
Which is like batch processing images and LiDAR data in hard real time deadlines with power efficiency.
Yeah.
and they test the people in
There was a very good line by, I forgot his name again, the statement.
Robert Ram.
Robert Ram. Yeah. He had a really, really good line that, we're essentially building these giant cathedrals on sand, on probability, and nobody seems to care. And I think there's a whole lot of truth in that. Like, our algebra model almost always, our programming model almost always follows the laws of algebra, except in the 1 in a million case where it doesn't, right? And then the plane crashes, right? Or with the hard real time, I mean, it's pulling teeth to get people to not talk in probabilities, right? Oh, the I have a whole, 6 orders of magnitude more compute power than I need on my Raspberry Pi, and so I will always be on time. Well, what if it, what if it does this check? I mean, it has to be another mindset, and I think that, the problem is that it's so hard to program in that other model because nobody's invested money into making it easy.
But isn't that the general problem, not just in the embedded domain, but in programming? That it's not a science.
But in embedded, the consequences are more severe.
Well, we have a science that deals with non-determinism. It's called statistics. And yes, many domains deal with non-deterministic inputs. Graphic, like anything with user input and graphics with randomness. Robotics has a lot of non-deterministic inputs and non-deterministic outputs. And I agree with Odin that there's like a huge lack of, there's like a, I don't know if it's fear of statistics or something because we're programmers, not mathematicians, but you can like write a p-test on the results of your unit tests, for example, for a non-deterministic algorithm. And you can say with like, this has passed a p-test and it's statistically significant that my code will like meet this requirement. I wish, I had this is getting really off topic, but I had an idea for making
Go for it.
like that, and like, I think people should adopt that, because a lot of existing testing frameworks are like, this is a unit test framework where your test pass or don't. And that doesn't cap, and people don't know how to deal with non-deterministic tests, for example, and they say like, don't put something like processing like network calls in your unit test because that's not deterministic. Well, how do I test it? I don't know. Yeah.
Yeah, I mean, going back to my, continuing down this branch off.
Unrelated to
Going back to my talk, the fact that the correctness of one thing, depending on your programming model, depends on all the other things, means that you cannot unit test it, right? Especially if you think about things like scheduler phase shift, and if you're allocating, I mean, if you're using a normal heap, then every allocation that has happened in your program from the beginning, so basically all the timing from the beginning of power up until that point are relevant to whether or not you're going to have a data race at that point or not. I mean, not only all the external inputs, right? So that it's just impossible to test or even reason about in anything besides guess and pray. Yeah.
I want to go back to what you asked about, which is the strategy about how to move forward. And part of that, I think, is the fact that, so we talked about the idea of a namespace, and maybe specifically embedded might not be too focused. I now think that that's probably true. Any problem that we're going to talk about crosses over into other domains. But we also talked about the idea, Odin and I actually talked about the idea that we have to progress carefully. And one thought that we definitely are thinking about is the idea that we need some sort of library that allows people to gather their usage experience and also prove to the community that embedded programming can be reusable. Just like Boost has popularized the reuse idea under an open community examination framework. Now, the reason Boost was created was because at some point, it also was created in a backwards manner. At some point, people realized that proposals were moving too slowly through the C++ standard library process. And the only way they could get more libraries in was to do it outside of the C++ standard library. And in effect, what Boost became was a test bed. It was like, it was like an Edwards Air Force Base. This is where you test out libraries first. And as you can see, every intention is to take Boost libraries and inject them into C++. 13 out of 14 libraries were added to C++ 11. And it's going to continue to happen. Now,
Can I interrupt you for a really smart-ass remark?
Sure.
So now that library acceptance and the Boost verification process is just traffic jam and things are moving very slow, we need to branch out of Boost.
Oh, I agree. In fact,
I mean,
Boost
why
is-
isn't Chris's state machine lab? That's probably one of the most clean pieces of template metaprogramming I've seen, including BridgeAnt, which I think is a great library.
So I think I can explain some of that. Over time, Boost itself has also become a bit of a bottleneck because as fewer people, participate. So at the beginning, it was a hot bit. You know, you could get lots of people to review and things like that. But that was 5 years ago. Over the last couple of years, I've noticed that Boost has slowly reached the point where it's, you know, the participation has declined. Maybe it has to do with David Abraham's departure to Apple, maybe not, I don't know. But
It's also because I think it's victim of its success because now we have more
libraries.
users
Yeah.
for libraries and
Yeah.
developers.
Yeah.
And
Also,
users doesn't care about the process.
It's way easier just to get code out there in a way that's easily accessible.
Yeah, nowadays you can self-publish, you can do GitHub, which is why I don't think Boost is necessarily the thing we have to do. But it's a model. It's a model because what we're saying is you've got to show the thing to work in public. Then you get it into the standard. Okay, it makes it much more easier to argue for things to go into the standard if it's already been in Boost. And then you create a guideline around it. And if we can do something like that progressively, mind you, it's a slow process. I hate to say it, these things do take time. You could probably slip a few features here and there into the standard, and you might even argue that it's really good for embedded programming, like no return or things like that. But you cannot get the hard features in. You are not going to be able to say, I want you guys to completely remove exception handling, because that's just not going to happen.
The question that was on the reflector lately was, how do I get stuff in there? Do I take my own and send a link? Do I get someone to pull it in?
It's an excellent question, and to be honest, I've been derelict my duty too, following these things. And one of the things we could do, and this could be the namespace, instead of saying it's embedded or games programming, it could be just an SG14 namespace. That's just a straw man. And if we can have let's just say for argument's sake, it's SG14. Then you could also have some sort of SG14 review committee internally. Because SG14 already has the membership and somewhat the structure to review these things. I mean, we would have to set something up. I mean, I'm not the best person to set these things up because I know how big my workload is. But that's one possibility, and I actually really agree with your suggestion, Paul, in that direction. I actually hadn't thought of it, so thank you.
So, I mean, the repo you're referring to, actually SG14, is kind of just a collection of disparate stuff which may or may not be production ready or at different levels of maturity.
Right.
And it is, maybe unlike Boost, it is important to be able to change your API in breaking rates.
Well, that's what it is now.
Yeah.
But I think it still needs, I mean, we need some common scratch space where we can just collaborate on things.
Yeah, but then once you get past that scratch space, we can create a repository that is essentially much more finalized, accepted.
Finalized enough that like a broader audience tries it out and provides some later feedback.
Well, one of the things that we've been noticing in the Quasar library, which kind of the maintainer admin guy is here, Carlos, actually, no longer me because I don't have time. But and I'm stupid when it comes to JIT. I don't know. I'll publish your pay anyway. One of the things we've been noticing is. In abstracting things for other domains and having other use cases, we also need other infrastructure, right? So we wrote our own metaprogramming library because others aren't fast enough. And we're probably gonna, I mean, Yonatan doesn't know this yet, but he's gonna write us allocators.
So an interesting point is, with regards to standardization, is there's the standardization as a design specification, and then there's quality of implementation. There's stuff like Variant, which we saw in Chris's talk. Variant optimized very poorly for the visitation to build a state machine compared to Chris's implementation. And I think We don't know why that is. It might be because of the nature of that data structure will poorly optimize. It might be because the design specification is not something that could optimize well, right? And that's, I think an open question is, do we need a better standard, or do we just need better quality of implementation for this use case?
I think we need QOI to be taken more seriously during the standardization process. Because for some tasks, I mean, yeah, you can just end with them because, yeah, I mean, the specification, as you said, is clear and there is not much leeway on how to implement that. But sometimes you have very different way of implementing simple stuff, and the fact that the standardization process doesn't care about QOI is, I think, an error.
Well, there's also as a counter argument to that, not just to be contrarian, we can specify whatever we want, and if nobody implements it, we're screwed anyway, right? Like, there's no, like, king of the world that says Clang has to implement that. And if we put a bigger burden, I mean, we're basically dumping an enormous burden on library. I mean, okay, what are they going to do with the man years that went into file system and ASIO and things like that? I mean, literally, and not just somebody at a college man years, expert man years. I mean, is Microsoft going to like try and clone STL, or are they going to hire like 4 more people, or are they just going to? Is everybody just going to take Boost and slap SDD in front of it? And if they differ, do we really want that, right? I mean, I think there's I call it surface area for lack of a better word. I mean, the ways you can notice that your implementation is different in file system and ASIO is bigger than vector, right? So we're increasing kind of the visible side effects of different implementations. Do we really want different implementations?
So one concrete suggestion of should there be, my answer to the should there be an embedded namespace, embedded library is, I think careful policy-based design in the standard library will answer a lot of questions. There was recently a blog post about the advantages and disadvantages of that, but I think policy-based design makes a lot of sense at the level of data structures. And the policy-based design interface in the standard library right now is really not good. And it was kind of, having talked to people about like why the allocator interface for vector is not awesome to use, I think they actually said because we designed it to be hard to use because we didn't want people to use it.
What the?
Tomato interface is hard to use correctly.
He said in his blog that policy-based vocabulary types are not a good idea.
Yeah.
I read that you're talking about my blog post.
Really good blog post on this.
Feel free to join.
It's your own but I think that's true, but it's truer for other domains, because if you have 32K of Flash, you are not putting a 1,000,000-line program in that, right? Like, you can harmonize that all of your policy-based vocabulary types are the same type. You generally own more of your code than if you're writing an app, right? In an app, you're writing like a pro mil of the code or something, right? Whereas right now, we're writing all of our code. So, yeah, there's a huge domain difference there. And yeah, I mean, policy-based class design is the solution to a lot of this stuff in my mind. Like, okay, don't like exceptions, why don't we make an on-error policy? Don't like slice size, make that something you can define in the allocator.
So these are the kind of big changes.
Yeah.
That's not going to take unless we really do some serious convincing evidence.
Yeah.
We're not going to be able to get the whole committee to go, let's just completely create a whole new policy that allows these other things.
Yeah.
Because they don't see the need of it, right? No matter how much evidence, but the only way we can do that is we put a lot of evidence in front of them and say this is necessary. And at that point, they might make this change. I mean.
Well, but I mean, now that I've shaved an entire yak, my opinion on the embedded namespace is we should build what we want to put there first, and then talk about, I mean, it's essentially bike shedding, talking about this. I mean, I'm a little biased because I like Quasier, but I mean, what we're trying to put together there is, you know, I mean, we could be completely wrong about how to solve this problem, right? I'm still convinced we're right, and the fact that we're gaining contributors, some of which are super intelligent, is kind of a sign that we might be right. But I think, you know, I think we should have the ability to fail, because we're essentially, in my opinion, I'm grouping us together in here, XPCC and Quasier.
We have 21 users together.
But and 20 of them are yours. No. This is the first time people have used these tools to solve this problem in any sort of public way, and so it's, I mean, the failure probability is actually relatively high.
I'm kind of scared that languages like Rust are just going to overtake it, and then we can put as much work into C++ and embedded, but it's still a superset of C. So maybe all of the assertions that you talked about, to me it was just, oh, you mean Rust? Well, I mean, I'm not advocating, I mean,
So-
again, we have different requirements, but
So you might be right, but I mean, we're talking about, you know, millions of lines of legacy code. I mean, I always think that, yeah, great, we could switch to pure functional programming, and all the parallel problems will go away. But that's just not going to ever happen. And it may be true that in about another 10 years, C++ totally disappears. In fact, I kind of expect that, because every 30 years, a new language generally invents itself. Something happens in the industry such that usually every 30 years, a brand new language comes
3 years
along.
or 40?
30 to
years.
40, yeah, maybe. Because C++ came along about 30, it's about 30.
So we've gone through
40.
3 of these iterations of history.
C++
So
is actually lasted
the sample
long.
size is not so big.
Yeah. But whatever that happens, we can't prepare for it. We just have to prepare for what we have right now. And right now, my best bet is C++. And yes, I'm probably deeply biased.